Hi, welcome to the video about finding the range of a function. Recall that the range of a function is the collection of all possible outputs. In the previous videos, we've talked about domain, which is the valid inputs into a function. So now we're going to explore what the outputs would be. In this problem, we're talking about dropping an object from a cliff. So the function h of t is equal to negative 9.8 t squared plus 150 represents the height of an object after t seconds of being dropped from a 150-meter cliff. Find the domain and the range and write in interval notation. So here we have a function that maybe we're not quite familiar with how this looks or acts, but we're gonna talk about it anyway and graph it and get some more details about it. So let's just talk about the domain. So the domain, reminder, is our input, and so our domain is t, and t in this case, it says t is seconds, so it's time. So because this is a problem in context, we need to kind of think about what would be valid times. Negative time is not going to be valid when we're dropping something from a cliff. So that means but 0 is valid. That would be the right before you let go of some object. So we can be equal to 0. But our domain's going to stop when it hits the ground. Our input, the time, we would say would stop, because once it hits the ground, it's not going to continue falling. So, when would it hit the ground? Well, we would be solving this function when is t, what value of t makes the height 0 when it hits the ground? We'll come back to this in a moment. We're going to graph this to find that answer. The range, though, are what are the valid outputs that are going to come out. So certainly, let's see, at h of 0, just kind of see what happens. Right before we let go, what's the height going to be? Well, I can do this algebraically, or you can think in real life, where's this? What's the height of the object going to be if you haven't let go of it yet? Well, it's at a 150-meter cliff, so this will give us 150 because this component 0, that's just 150. So the range will include 150 meters. Is it going to be more than 150 meters? Is it going to go up into the air? Well, we're not throwing it up into the air. This function doesn't model throwing it up into the air. It's simply being dropped. So the biggest part of our range is going to be or the greatest number of our range is going to be 150 meters. What is the lowest part of the range? What will be the least number for the height in context? Well, when it hits the ground at 0. So here's our range. The output range will be 0 to 150. Now it seems kind of opposite of what's going to happen in real life, because it's going to go from 150 feet down to, or meters, sorry, down to 0 meters. But remember, when we write in interval notation, it goes from the least value to the greatest. So let's go back to when is the height, or what time, we're trying to solve for t. What value of t makes the height 0? So let's try graphing this. We're going to go to Desmos here. Whoop. We're going to type in our, let me get this, scroll down a little bit for you. We're going to type in h of t equal to negative 9.8 t squared plus 150. I see that I have, can't see everything yet. So let's change our graphing settings. I know that my valid input just starts at 0, so there's no reason to see anything in the negative range. And then I know that for my y-axis, I'm really just interested, this is the range. The y-axis represents the height. So the lowest height that I need to see is 0. And the greatest height we know is 150 meters. Now you can't see all of that on the screen. Let's see if I can make this a little bit better here. There we go. So now you see this kind of models, it's not the picture of the object falling to the ground because it's going to fall straight down. But what we see is that the maximum height is 150, and as the x-axis represents time, as time goes on, we will hit the ground. So let's zoom out just a little bit and click on this, and we hit the ground. Remember, the height is our y variable, the height 0 at 3.912 seconds. So that means our domain, our valid domain, is from 0 seconds to 3.912. And including that, because that's the value approximately that makes the when the object's going to hit the ground. So here's an example in context. And we could have gotten all of that from graphing that function. We could, so if you go back, we could have simply graphed the function, considered the context and say, okay, we're going to start at 0, and that means its maximum height was 150, and then down to when it hits the ground, when the height is 0, when our y value is 0, we're at 3.912 seconds. Okay, so that's kind of a problem in context. So again, the range, you will have to also consider the context of the problem. Let's take a look at some algebraic questions. So without any context, what's going on here? Let's look at f of x is equal to x squared. Find the domain and range, write in interval notation. So domain. What are the valid inputs? So remember, we start with all values, all real numbers, and then if we have a denominator, it can't be 0. If we have a square root, it cannot be negative. And here we have neither of those. So are all real numbers valid? Can I plug in any negative number? Yes, if I plug in a negative number, I can square it and it becomes positive. Can I plug in can I plug in 0? Can I evaluate f of 0? 0, I can square 0 and get 0, so that 0 is okay. And any positive number. So again, domain's all real numbers. The range. What is our range going to be? Well, reminder, what does x squared look like as a function? X squared, here's 0, 0, 1, 1. When I square 2, I get 1, 2, 3, 4. It's a parabola like that. So the range are the y values. What's the smallest y value when you square a number? What is the smallest number that you can get? Well, if I look over here on my graph on the y's, I can get 0. I cannot get a negative number after squaring x. So my range starts at 0. And again, I'm looking at the y-axis here for the range, starting at 0, and then it goes up to infinity. It will continually grow. The larger the number I plug in for x, the larger the range will be, or the output. If I plug in a very small negative number, meaning very negative, then I square it's going to be a very large positive number. So my range is from 0 to positive infinity. Last example here. We have g of x is equal to the square root of 2 minus x. Find the range. So recall when we did this problem that the domain is negative infinity to 2, positive 2. We did that on a previous video, so let's talk about what the range is. And we're going to write it in interval notation. Well, when I take the square root of something, what kind of outputs happen? What kind of numbers do I get? I can get positive numbers, and I can get 0. So the range is 0 to positive infinity. There's no bound on how large of a number I can get when I take the square root. So if that seems a little like, huh? But my domain is negative numbers up to +2. Why are the range positive numbers? So let's graph it and see what happens. So we'll start with g of x equal to square root. Find that square root key, square root 2 minus x. Okay, and I can't see anything. Why can't I see? Well, because my graph is, I can see very little down here, my scales from the last problem. So let's just revise the scale from -10 to, well, we don't need to make it any larger than 2, but I'll make it 5. The y-axis, we'll just start at -5 because we know we aren't going to get any negative numbers in this problem, up to 15. Okay, so now here we start to see that the smallest y value I can get, so I look at my y-axis, the smallest y value I can get is down here at 0. So if I look at that point, 2, 0, there's my y value of 0. That's the part of the range. If I look at any point on here, now my y value is 1.4, and now it's 2.82, now it's 3.385. As I continue to look at this function, the y values are constantly increasing, okay? And that will happen forever. So there it's 7.684. That's why we say that the range is from 0 to infinity. All right. For you, I want you to use graphing technology, a graphing calculator or Desmos, and graph those on a calculator or on Desmos and find the range. Find the domain and range and write an interval notation. So there's 4 of these. So the first one, f of x is equal to just simply x minus 2. Number 2, g of x equal to the absolute value of x minus 2. Number 3, h of x, the absolute value of x, and then minus 2 outside of that. And 4, k of x equal to 2 minus the absolute value of x. So a very similar problem to number 3. I want you to find the domain and the range and interval notation for all 4 of those, and try that before moving on to the next video. Bring those answers with you to class.